So this is 4.19 or 419. Formic acid is a weak electrolyte. What solutes are present in an aqueous solution of this compound? Write the chemical equation for the ionization of HCOOH. So since it says it's a weak electrolyte, remember when it dissolves in solution, it doesn't completely break up into ions. It only does a little bit. And so when it dissolves and when it forms the tiny bit of ions that it does, it'll make a few H's because it says it's an acid, and remember acids are always a good source of H+, and then it'll have the remainder of the acid HCOO with a negative sign here. But remember there'll only be a very few of these, and so to indicate that we'd actually use a double arrow like this to indicate most of them go back this direction. So in a solution we'd have lots and lots of these, we'd have a tiny amount of these, and we'd also have a tiny amount of these. So those would be the ions or solutes that are present in the aqueous solution. This is 4.20. Acetone is a non-electrolyte. Hypochlorous acid is a weak electrolyte, and ammonium chloride is a strong electrolyte. What are the solutes present in aqueous solutions of each compound? So the weak electrolyte, or the non-electrolyte, the non-electrolyte first, this one, CH3COCH3, would just exist as this. Nothing would happen. It wouldn't break up or form any ions. That's what it means to be a non-electrolyte, is it doesn't have any plus or minus charges on it. The weak electrolyte that it says is there, HClO, that would just slightly break up, just like this one did. And so you could draw a tiny arrow going this way, but there'd be a giant arrow going back this way. And since it's an acid, it'd give us a little bit of H plus and a little bit of the ClO minus. The key is that there would only be a tiny amount of each of these right here. That tiny amount can make a difference, but there's only a little bit. Letter C, on the other hand, a strong electrolyte, NH4Cl, that would completely dissociate. It's a strong electrolyte, and so you'd end up with NH4 plus and Cl minus in this one. Lots and lots of these. In letter B, if 0.1 mole of each compound dissolved in solution, which one contains 0.2 moles of solute particles, which contains 0.1 mole of solute particles, and which contains somewhere between 0.1 and 0.2? Well, we can use these ideas to help us figure it out. This one, since this is all that's going to dissolve, is just going to be 0.1 moles of that solute solution, because nothing else dissolves. It doesn't break up into anything else. This one right here completely breaks up, so it goes from 1 mole to 1 mole of this, and 1 mole of this, and 1 plus 1 is equal to 2. So this will be our 0.2 mole one right here. And the one that's somewhere in between, well, there'll be some of this right here, and there'll be a little bit of this and a little bit of this, so it will be somewhere between 0.1 and 0.2, because maybe there's like 0.9 of this left, and now we have 0.1 of this and 0.1 of this, or something like that, which adds up to more than 0.09 of this, and maybe we have like 0.01 and 0.01. Now we have more than 0.1 right between 0.1 and 0.2. Anyway, strong, weak, and non-electrolytes, number 19 and number 20.